Hello, I'm Jumo Kim from Korea University. Today I will propose the interesting project named Deep Learning with Convolutional Neural Networks for Auto-User EEG Classification and Visualization. First of all, I'm doing a research on MI-EEG classification. EEG is an electrophysiological monitoring method to record electrical activity on the scalp that has been shown to represent the macroscopic activity on the surface layer of the brain underneath. And motor imagery, simply called MI, can be defined as a dynamic state during which an individual mentally simulates a physical action. So, the objective of this project is to improve the performance of the MI-EEG classification by proposing your own method. Also, if you achieve the first goal, the reason why your proposed method works better than the baseline method should be discussed with sufficient visual data by using GradCam or layer-wise relevance propagation score, or whatever you want. The dataset used for this project is BCI Competition 4-2A dataset. We selected 4.5 second lengths of each trial for 0.5 seconds before the start cue to 4 seconds after the cue. The dataset consists of 4 classes, which are left hand, right hand, feet, and tongue. 72 trials are given for each class, and 22 electrodes were used for recording EEG signals with 250 Hz sampling rate. Finally, we applied bandpass filter between 0.5 to 40 Hz. There are 2 sessions in this dataset. The first session will be used for training the network, while the second session will be used for evaluating the network. There are 9 subjects in this dataset, where the experimental result of each subject should be provided. In this project, I implemented EEGNet for the baseline, where EEGNet consists of 3 blocks for spectral, spatial, and temporal feature extraction. The detailed information of the network and implementation is uploaded in GitHub, so please refer it. After training the model and your own model, you should provide your interpretation of the result with sufficient visual materials. For example, you can use GradCam to show temporal attention on the raw EEG signals. Or you can calculate layer-wise relevance propagation score, which is called LRP score, to provide the neurophysiological interpretation on spatial domain. Codes for calculating LRP score will be given, and other techniques are welcomed. So to sum up, what you have to do is, first, you have to train and evaluate the baseline model. Then design your own neural network and achieve better classification result. You can modify the baseline model or propose a new framework. After that, compare the baseline and the proposed method. Explain why your method works better than the baseline, with sufficient visual materials. For the visual materials, please refer to the previous slide. Finally, submit the prediction of your own neural network using the test dataset. I will evaluate the result and share the result with you as soon as possible. These are the references, and thank you for listening. Bye bye.